Okay, here is a second example of divisibility. I chose this example because in this example there are two different numbers being raised to a power, the 7 and the 6, and also this is an example that's only true for odd powers of n, and I think you should see that. Okay, starts off the same way. By now you should be knowing this by heart. When n equals 1, 7 to the 1 plus 6 to the 1, guess what? 13. True, therefore, for n equals 1. Let's try the next value. Okay, what's going to be, and it's not going to be n equals 2, is it? It's going to be when n equals 3. We know 7 to the 3 plus 6 to the 3, that's going to be 3, 4, 3, plus 2, 1, 6, 5, 5, 9, and as everybody knows, that's 43 times 13. Therefore, that will also be divisible by 13. Therefore, true, n equals 3. Okay, now we come to the next bit again. Assume true for n equals k. What are we assuming? Assume that 7 to the k plus 6 to the k is equal to 13 times some whole number. M is an element of the whole numbers. And we want to prove true as usual for n equals k plus 1. Prove true for n equals k plus 1, I said. Oh no, k plus 2. Because we're assuming, of course, that this is some odd number, and the next odd number is 2 along, and you'll find if you made the mistake of putting in the k plus 1, you could not work out the algebra and simplify to 13 times a number. i.e., we want to show that 7 to the k plus 2 plus 6 to the k plus 2 is going to be 13 times some whole number. Okay, now we would always like to re-express this in terms of our assumption. So we know that the left-hand side, sorry about the little squeaks, is going to be 7 squared times 7 to the k plus 6 squared times 6 to the k. Okay, that's 49 times 7 to the k plus 36 times 6 to the k. But we don't ever replace two of them. We could say that either 7 to the k is 13m minus 6 to the k, or that 6 to the k is 13m minus 7 to the k. It'll make no difference. So let's replace the first one. That's 49 times 13m minus 6 to the k plus 36 times 6 to the k. We can already see this is going to come out very nicely. Equals 49 times 13m minus 49 times 6 to the k plus 36 times 6 to the k. And that's going to be equal to 49 times 13m minus 13 times 6 to the k, which we can see has got a factor of 13 in it. Not only that, but because m and k are whole numbers, we know that what's in brackets there must also be a whole number. Therefore, we know again that if true, n equals k, true, n equals k plus 2. We know it's true for n equals 1, 3, and therefore true for n equals 5, 5 plus 2, 7 plus 2, all odd n.